this is chapter 4, section 2, reflections. Can be found on page 181. All right, so a reflection is a transformation that uses a line like a mirror to reflect a figure. The line is called the line of reflection. So if you take a look at the image on the left, so ABC, the triangle ABC, as you notice, it's reflected over the y-axis, okay? So this is our y-axis. Each of the points are reflected over the axis. So C becomes C prime, reflected over the axis. A becomes A prime, and B becomes B prime. So it's just a reflected image over that line, and that's called the line of reflection, okay? There's some images here that show reflection as well. So there's a mirror, and then there's also the reflection off water. So just to give you guys an idea of what a reflection looks like. Okay, so reflections, how do we make them? So let's take the line M, and we're gonna make our line M our line of reflection. So M is our line of reflection. Okay, so if P, our point right here, is not on our line M, or our line of reflection, then M is the perpendicular bisector of P to P prime, or if P is on M, then P is P prime, okay? So basically what this is saying is if P is not on our line M, then the line of reflection is going to become the perpendicular bisector. So it's going to split the distance between our point P and its reflected point. It's going to split it into two equal parts, and it's going to be perpendicular to our original line, to the line of reflection, which is M. Okay, so that tells us two things. It tells us that it's the same distance, right, away from our line, and it also tells us that the slope of P to P prime is perpendicular or opposite reciprocal to the slope of line M, okay? So the slope of I'll label it line M, is opposite reciprocal to the line segment P prime, okay? And then if our point P lies on the line of reflection M, then P prime is just that same point. So that's this second image over on the right, okay? Where P lies on the line of reflection. Because if it's 0 units away from the line of reflection, so you're just reflecting it onto itself. Okay, let's try some reflections, and they're easier than it kind of seemed in the last portion. So let's graph ABC with vertices A at 1, 3, B at 5, 2, and C at 2, 1. So A is going to be at 1, 3. That's over 1 on the x-axis, and up 3. That's going to be right here. This will be A. Remember, your first coordinate is how much you move horizontally or in the x direction, and your second coordinate is how much you move vertically in the y direction. So 1, 3 would be over 1, up 3. B at 5, 2 would be over 5, so all the way over here, and then up 2. So let's go up 2. This is going to be B. And then C would be over 2, up 1. That's going to be right here. Over 2, up 1, and that will be C. So let's go ahead and draw our triangle. Looks like that. All right. And it's image after the reflection described. Okay. So I'm going to use a different color to draw our reflection line. And in the line N, which is x equals 3. So if x equals 3, that's right here, right? it's going to be a vertical line because no matter what y is, x is going to be 3. So let's draw a dotted line down this area right here at x equals 3. Dotted line. And we're going to label this line n, right? Because it says in the line n, x equals 3. Now, it's nice when it's a vertical line, okay? Because all you have to do is count the units that our points are away from that line and then reflect it over. So in this case, what's the slope of our line right now? It's a vertical line, so the slope is undefined, right? Its m is undefined. Okay? So technically what we're doing is each point we are reflecting it over this line. So the slope of the line segments is going to be 0. Okay? So we're moving A 2 units horizontally to get back to this line. So we're going to move it 2 units over the line. So this is going to be our A prime. Okay? Let me take away this line here because that's going to cause problems in a bit. Sorry, guys. Let me just redraw this. Perfect. Okay. Now, B prime. B is 2 units to the right of our line of symmetry. So we're going to go 2 units to the left of the line of symmetry and put B prime right here. Okay? Because it's an exact reflection over the line. And C prime is 1 unit away. It's 1 unit on the left. So let's go 1 unit to the right. This will be C prime. Okay? Now, the reason I talked about slope, okay, was because if you were to draw a line segment from A to A prime, that would have to be the perpendicular bisector of that line. So let's say I drew this line right here from A to A prime. N is going to be our perpendicular bisector of this line segment A prime, okay? How do we know that? Well, is it the same distance to the left and on the right? Yes. The distance from A to the line of symmetry, N, is the same distance from N, the line of symmetry, to A prime. So yes, that happens. And are the slopes opposite reciprocals? Yes. Yes, they do form a 90-degree angle. Okay? All right. So, again, our red triangle, I know this got kind of sloppy, but that is our reflected image. Okay? Let's try another example. All right. So we're going to take this same exact triangle and we are going to reflect it now over a different line, line M, which is going to be y equals 1. So let's go ahead and let's draw the same image. So I'm going to use a different color for this one. I'm going to use red. Actually, no, let's use black again to start with. So 1, 3 is up here. This is A. 5, 2 is over here. This is B. And then C is 2, 1. Right here. Draw our little triangle. Beautiful. And y equals 1, okay? That's going to be right here. So we're going to draw a horizontal line at 1. And we're going to be reflecting over this line. The easiest one here, okay, is, and this is line M. The easiest one here is the point C, right? Because C prime is just going to be the same point, okay? Because it's on our line of reflection or our line of symmetry, okay? B is 1 unit above the line, so we're going to go 1 unit below. This will be B prime. And A is 2 units above, so we're just going to move that 2 units below. So this will be at 1, -1. Okay? This will be A prime. So our new triangle looks like this. Oops. There we go. Just like that. Okay? It is completely reflected over our line M. All right, now we're going to graph FG with endpoints F at -1, 2, and G at 1, 2, and its image after a reflection in the line, this is where it gets tricky, y equals x. So now we're not using a horizontal or a vertical line, we're using the line y equals x, okay? So first off, f is going to be at -1, 2, and G will be at 1, 2. So let's go ahead and plot those. -1, 2 is going to be right here. This will be F. And then G will be at 1, 2. This will be right here. That will be G. Okay? So this is a line segment, it says, FG. So let's connect them. And its image after reflection in the line y equals x. So our line of symmetry is now a line, okay, that is not horizontal or vertical. It's going to be, so our y-intercept is 0, and our slope is 1. So we're just going to move up 1, up 1, up 1, up 1, up 1, just like this, 1, 1. And same thing in the negative direction, down 1, to the left 1, down 1 to the left 1, and this is our line of symmetry, okay? Remember, because if this was in slope-intercept form, right, our m equals 1 and our b equals 0. So we know it crosses the y-axis at 0, which we plotted our 1 point here, and then our slope is 1, so we're going to go up 1 over 1, up 1 over 1, and then down 1 to the left 1, down 1 to the left 1, okay? All right, so we're flipping it over this line. Now, if you can visually see it, G is going to go right here, and F will go boom, 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 right here. Okay? That's G prime, F prime. Okay? Only if you can see it. Now, I would just look at each point, right? Because this point, if we were to draw a imaginary line that is perpendicular to our line of reflection, then we're going to move that same distance to get to G prime. Same thing with F. Perpendicular, perpendicular. Now, what you have to think about is, how did we actually find this? We thought of a perpendicular line here and a perpendicular line here. The slope of y equals x is 1. So the slope of our lines, these two right here, is going to be m equals -1. So if we were to look at this line from F to F prime, that line segment, right? Now, if the slope is -1, right? If we go down 1 and we go over 1, this should be one of our points. And if we go down, but we don't want to go down 1, we want to go down 1/2 and over 1/2, this is where our line segment, I mean, I didn't draw it completely right, but this is where our line segment should cross the line of symmetry, right? And so all we're going to do is go down 1/2, over 1/2, and down 1 over 1, and we'll end up at F prime, okay? We're doing the exact same thing we did to get to the line of symmetry to get to F prime, okay? And let's look at G. G's a little bit easier. For G, we go down 1/2, over 1/2, and then same thing, down 1/2, over 1/2. So our slope is the same, or our movements are the same on each side of the line of symmetry, okay? And remember, our line segment G, GH, and F, F8, G, G prime, and F, F prime are, their perpendicular bisector is that line of reflection, that green line that we see right here, which is line y equals x. Okay? Now, this seems a little complicated. There is a much easier way that you're about to learn, but I like if we can understand it conceptually, then when we learn it, when we learn the trick, it makes more sense later on. So, G's point was 1, 2. So by the coordinate rules, right, G prime should be at 2, 1. And it absolutely is. G prime is at 2, and we go up 1. So that's exactly where G prime is. Perfect. Let's try it for f prime. F prime should be at 2, -1. Okay, let's check it out. F prime is at 2, -1. Beautiful. Okay, so these coordinate rules are extremely helpful because reflections sometimes can be very difficult to plot. So definitely you need to know in the previous one, right? It would take a lot of work, okay? Here's our trick, okay? So these are your coordinate rules for reflection. You can star this, make sure that you memorize this. This is super important right here, okay? Draw a box around it. If AB is reflected in the x-axis, then its image is the point A, -B, okay? That's the x-axis. If AB is reflected in the y-axis, then its image is the point -AB. If AB is reflected in the line y equals x, then its image is in the point BA. And if AB is reflected in the line y equals -x, then its image is the point -B, -A. Now, let's go back one slide and let's check out this y equals x. Let's check that that the image of each of those points is going to be BA. Sometimes you cannot conceptualize it like I did. So definitely memorize these coordinate rules for reflection. And we're actually, on the next slide, we're going to deal with y equals -x, okay? So our rule for y equals -x says that we're going to flip A and B. So now B is going to be our x coordinate and A is going to be our y coordinate, and we're going to make them both negative. Next slide. All right, so we're going to graph AB line segment with endpoints 3, -1 and 3, 2, and its image after reflection in the line y equals -x. Before I do anything, guys, what I first want to do is I want to find what A prime and B prime are going to be, okay? Because knowing our coordinate rules, and now we can use them, y equals -x, all we're going to do is we're going to follow those rules. So A prime is going to be +1, -3, okay? We made the -1 positive and we made the 3 negative. B prime is going to be, let's take the y coordinate 2, make it negative, and let's take the x coordinate 3 and make it negative. All right, and then we just plot them all, okay? So our first point, which is A, regular A, not A prime, is going to be 3, -1. That's right here. This is A. Our second point is 3, 2. That's up here. That's going to be B. And our line of symmetry, okay, let's go ahead and plot that as well. That's going to be y equals -x, so it's going to be a slope of -1. This line right here. Remember, in slope-intercept form, y equals -x tells us that b is 0, so it has to cross the y-axis at 0. And our m, b equals 0, and our m is -1. So it's going to have a -1 slope. Okay? So the line segment AB is then just going to flip over this line of symmetry. And let's see what it turns into. A prime is now 1, -3. That's right here. A prime. And B prime is now -2, -3. That's right here. These line segments should be exactly the same length. Okay? Because we're not changing the shape at all. We are just reflecting it over a line. Okay? And it looks like they are. Does this make sense? Well, if we drew a line connecting them, those look about the same distance on both sides, and they do make a 90-degree angle with our line of symmetry. Let's draw a line from B to B prime, and same thing. Looks like it would make a perpendicular line. You could also calculate it, right? So you could find the slope of B prime B and make sure that it is 1, because the slope of our original line of reflection is -1. So the slope of our perpendicular bisector, or the line segment that's perpendicular bisected by that, should be 1, right? Because it's perpendicular. All right? Okay, lines of symmetry. Okay, that was a lot, but this is a little bit simpler. Okay, lines of symmetry. A figure in the plane has a line of symmetry when the figure can be mapped onto itself by a reflection in a line. So let's take a look at A. We've got this shape here. It has two lines of symmetry as we see from down below. Okay, you can split it horizontally and you can split it vertically. Okay. B has a total of 6 lines of symmetry. Okay, that is a perfect hexagon. So in this case, each of those sides are equivalent. So they're exactly the same length. That's why it's a perfect hexagon. And C looks like kind of like a kite. It only has one line of symmetry, okay? And that's the horizontal line of symmetry, all right? So basically, if you were to flip over any of these red lines, okay? So for example, B had a lot more, it would be the exact same image on the other side, okay? So all of these points on this top side, if they were reflected over the red line, it would match up completely with the points on the green side. Okay? That's what a line of symmetry says. All right, so let's determine the number of lines of symmetry for the figures here. So for number 12, I can see that we can divide it into this way. Now, that's a really bad line, but you get the picture, okay? If we were to flip it over this line, it would be the exact same image on both sides, and we could divide it this way as well, vertically, okay? So this one has 2 lines of symmetry. Number 13, I see that it is completely symmetrical in this direction, going from one of the corners to the other side, in this direction, in this direction, and in this direction. So we just drew 4 lines of symmetry. Oh, there's one more. There's also this one. 5 lines of symmetry, okay? So 13 has 5 lines of symmetry. And 14, there's only one, and it's this one down the middle, okay? There's only one because any of the other lines, you would not get the exact same image on the other side, okay? Lines of symmetry for the figures. All right, could you draw a pentagon with no lines of symmetry? And by pentagon, I mean hexagon. See if you can draw a hexagon. That's 6 sides. With no lines of symmetry. Go. This is a sample answer, okay? Remember a hexagon? That should say hexagon. So, could you draw a hexagon with no lines of symmetry? Yes, here's a sample answer. So, this image clearly has no line of symmetry. There's no line you could draw through it that would divide it into 2 equal parts, or to 2 parts that when you fold over that line, it's going to be the exact same image on the other side. So this one has no line of symmetry at all, okay? Okay. Now, something called a glide reflection. So a composition of a translation and a reflection is called a glide reflection. So remember, compositions are combinations of 2 transformations. So we already learned about translations. That's just moving an image around. So moving all of your points a consistent vector length away. And if you combine that with a reflection, we call it a glide reflection. And we're going to do an example with those, okay? So let's take ABC with vertices 3, 2, 6, 3, and 7, 1. Let's go ahead and plot that really quickly. So 3, 2, that's right here. A, B is at 6, 3. That's B. And C is at 7, 1. So that's right here. This is C. And our first translation is we're going to not change the x coordinates at all, and we're just going to move all of the y coordinates down 6. So we're going to shift this down 6 units. So our C prime is going to be down 6. 1, 2, 3, 4, 5, 6. This will be our C prime. Our B prime is going to be down 6. 1, 2, 3, 4, 5, 6. This is going to be our B prime. And our A is going to be 1, 2, 3, 4, 5, 6 units down. This is going to be our A prime. If we were to draw both of these figures, they should look exactly the same if we did everything the right way. Beautiful. All right, they look good. And then we're going to have a reflection in the y-axis. So this is our y-axis. Okay, we're going to reflect over that. Now, if you're comfortable just being like, okay, well, I'm just going to completely project all of the points over on the other side, go ahead and do that. Now, I would like you guys to use the coordinate rules, okay? So that's where we're finding A is actually the coordinate 3. We're moved over 3 and then down 4, so 3, negative 4. Remember, if we're flipping over the y-axis, your x coordinate is going to be made negative, okay? So this is actually going to be negative 3, negative 4. So it's going to be right here. This is going to be your A double prime. Same thing for B prime. So this is at 6, negative 3. When you reflect over the y-axis, this then becomes negative 6, negative 3. So that's going to be all the way over here. This is going to be our B prime, or I'm sorry, double prime. And our C prime is at 7, negative 5. So our C double prime will be at negative 7, negative 5, which is all the way over here. C double prime. We draw this triangle. It should look like a reflected image over our line of reflection, which is the y-axis. And it does. Beautiful. Beautiful. All right, there's your homework. Good luck.